tonight, this with Professor Dr. Dolphy Gilpin. And tonight we'll be looking at radium with symbol Ra, radon with symbol Rn, and we'll be looking at the interrelationship of uranium, radon, and radium. And I guess plutonium, thorium, and lead will also come in during the radioactive chain. But we will basically look at radon and radium. Now, these two metals, we know one is a noble gas. I've been sort of causing the ambiguity sometimes with their symbols, and sometimes there's a bit of mixing up. But indeed, there's a bit of mixing up in the radioactive sort of decay and breakdown, because they could derive radon from radium breakdown. And so it causes a bit of, ambiguity sometimes, but it can be purely differentiable, or you could purely differentiate it. So we're going to look at them separately, integratively, and differentiatively. Okay, so here we have radon. And for one, you'll know that radon with a symbol Rn and atomic number 86, and the most available and long-lived radon, the radon gas, have atomic weight of 222 and probably a half-life of about 3.8 years, or days rather. So Rn 86 atomic number and atomic weight 222. Noble gas. Let's look at that one first, then we look at radium. So here we're going to now separate radium from our deck of elements here, that is in random assembly, random integration, random assembly. And we're going to try to extract radon, inert gas, with symbol Rn. And we're trying to get it right this time, because a lot of time there's a bit of a mixing up there with radon and radium. Radium has a symbol Ra, while radon has symbol Rn. So here we are. This is a radium. We will look at it. So let's extract it and separate it here. Let's try to find now 88226. That's the metal. Let's try to find the inert gas now, which is radium. Might be quicker just to make up a new card with it, because going through this to find it sometimes takes long. Seborgium here. Okay. And although we are trying to isolate radon, a lot of time is taken up here trying to just get the thing. So I might just write it up to be quicker. Einsteinium, europium. Here's a blank card. If I don't find it in this batch, I will definitely just write it up. Actinium, argon. This is what? Nil, quadrium, 104, metal, gold, silver, arsenic, aluminum, acetine. All right. I think it's going to be quicker just to write it up here. And then we know that we have 2 radon in the pack. There's a lot of cards here to go through to get this radon. We have the radium already. There would have been a lot of card here to sift through. Wow. Might be just quicker. These are R here. Radium. Okay, we got it. Radon rather. You see already I'm mixed it. Okay, so we have radium and radon. One is an inert gas, and that inert gas reacts only with fluorine to give you radium 2 fluoride or radium difluoride, but then it has its radioactive property because it's a radioactive gas. So radium 86 here. 86 atomic number and atomic mass of 222. Alright, so let's just fetch our notes here. And we're on radium. Are in radon. Okay, atomic number 86. Atomic mass 222 for the most stable and most abundant radium gas. Because you have some other radium there, the isotopes. And its ground state electronic configuration, Xeon Xe 4f145d106s2. The ground state configuration of the gaseous neutral radon is Xe 4f145d106s2. And radon is a radioactive noble gas. Its most long-lived isotope is of a half-life of about 3.82 days, which is the radon 222, right? And we say no, radium readily reacts with fluorine to give you radium 2 fluoride or RaF2 or radium difluoride. But it does not react with any of the other halogen group, family, like chlorine, iodine, and acetine, and bromine. It does not react with those, it only reacts with fluorine. Now, while radon gas is unreactive or not reactive, it is not explosive. And the World Health Organization, the WHO, has some statistics on it, the death per year by toxicity of radon, 21,000. World Health Organization, and death annually, of which 3 to 15% of this would be by lung cancer from radon toxicity. Okay, let's go in this direction. And we have to know that radon is radioactive gas. We have said it over and over again. And it derived from radon, from uranium, thorium, and radium breakdown. So we're getting this straight here tonight. The radon inert gas is derived from uranium, thorium, and radium breakdown. And the breakdown of this uranium and thorium from soil and groundwater, because uranium is found naturally among rocks and in soil. And by this breakdown, you get radon. Now, radon also dissolve in water, so it will dissolve in those groundwaters and things, but chemically it won't form anything. It just dissolve in the water there, and then if you drink that water, you become toxic by the radon in the water, the dissolved radium. Now, radon has about 4 daughters, and they call them daughters of radon. 4 of them, and what you have is the polonium-218, PO-218, lead-214, PB-214, and bismuth, Bi-214. Those are the atomic weights of the daughters, and polonium-214. So polonium-214 and polonium-218 are the daughters, and they are alpha emitters. And the other two, lead-214 and bismuth-214, are beta and gamma emitters. Now, at the end of this chain, you'll have a PB-210, which is more stable, and that one has the longest half-life for about 22 years. And that is the one, I believe, that is always shown for the lead, PB-210. All right, so let's continue. So that is just a brief introduction to radon, the inert gas, the radioactive inert gas, and which only chemically react with fluorine there, forming radium-2 fluoride. But most of its properties found in its radioactive property. Let's look at some uses of radon. So radon is used for testing malignant tumors, or rather for treating malignant tumors, and in experimental studies. So that's 2 uses of radon there. It's used in experimental studies and in the treatment of malignant tumors. Now, most of these applications with radium and radon are being sort of phased out, and other modern applications have been used. But these are what the basic application used to be. Fundamental application, treating tumors and that, and for experimental studies. Now, one differentiated or difference in radon and uranium at this moment would be that a use of radium, which is now symbol Ra, because we're going to look at it more extensively. Use of radium would be used in radiation as a radiation source, and in the treating of neoplastic disease. And let's really differentiate and specify that this is radium we're talking about, because radium and radium are so closely intertwined sometimes. Even by the symbols, sometimes there's a little bit of ambiguity. You have to think hard sometimes. So which one is Ra? Ra is radium, and which one is radon, the inert gas? Okay, which is Rn. So we're saying that the Ra, radium, is used as a radiation source and in the treating of neoplastic disease. Secondly, it is used as a radon source. Now, this radium is used as a radon source because when radium breaks down, it gives you radon, and so it is used as a radon source. And thirdly, it is used as radiography of metals in the industrial processes. And fourthly, as a neutron source in research. So that's the radium, the use of radium. So the radium is used as a source to give radon, which is the inert gas with radioactive property. And the radon now has uses to treat malignant tumors and in experimental studies. Now, okay, we're going to take a break here, and then we are going to look at the intertwined or interrelationship of uranium, radon, and radium. So let's just take a break here. That was basically radium, radon that we look at.